This video is a tutorial for the operation of the Abundance Project game. We have taken as our example for the tutorial as a study of the consequences of abundant infant and child health care. The tutorial demonstrates how to use thought experiments and simple models to uncover surprising and unintuitive consequences. As we uncover the consequences of the abundance, you will often hear me slip into the past tense. This is because the events I'm describing have already occurred. Our current infant mortality rate is 1/50th of what it was in 1850. So much of what I describe has already occurred and is called, as a name, the demographic transition. Well, let's not waste time. Let's get right into it. Here we have a very simple schematic of life. It's pared down to its bare minimum. On the left here, over here, we have people being born. And I have them for now being born at a constant rate. And then adults, here's children becoming adults. Adults eventually die. And occasionally, in this example, I have it about 50% of the time, sometimes children die and infants. So this is about as simple a picture of life as you can get. And what we're going to talk about in this series is what happens if children and infants don't die, or rather there's such an abundance of child and infant health care that almost every child lives. So let's create that in this picture. There we go. Now we have the abundance of health care, and you see in this picture now that no children are dying, and every child is becoming an adult that after some lifespan eventually dies. We can take our simple schematic of life and turn it into an even simpler influence map. What's an influence map? An influence map is just a picture of how various components of a system affect other components. So we can write our influence map like this, or draw it out like I've drawn out right here. What do these things mean? Well, here's a box that has child health care. Here's another box that has population. Here's kind of an arrow that indicates influence. And here's a little sign here that indicates whether the influence increases or decreases. In this case, we're increasing the amount of child health care, and so this box is green. If we were decreasing it, I would make the box red, for instance. So we're going to increase child health care, have a green box here, and we're going to ask, how does that influence the size of the population? Well, this is easy to see. If you increase child health care, more children live, and therefore the first thing that happens is the population increases. So this is basically the very simplest influence map we can draw of our child health care problem. Well, in our original schematic, we assumed that children were born at a constant rate, and of course that's not accurate. So let's fix that. Children come from adults of childbearing years. So if you have a few adults that are of childbearing years, you'll have fewer births. On the contrary, if you have quite a number of adults of childbearing age, you'll have several births. So let's just make an assumption for the moment. Let's assume that every adult is responsible for replacing himself or herself. That is, They procreate at a level so that they have effectively one child per adult. So let's see what happens. Uh, let's just hit the reset button and see what happens. I have 10 children being born here. Some of them are becoming adults, and some of them are dying as children. And each adult reproduces himself or herself. Well, uh, when you have infant death and childhood death, then eventually the population will die out because the children who die don't replace themselves. So let's watch that again. The way this works is I seed the system with 10 children and then see what happens. Okay. All right, here come the 10 children. All right, adult, death, death, adult, adult, adult. Each time there's an adult formed, a child is also formed. But eventually the population dies out because it doesn't replace itself. Well, let's look at the situation where no children die. Every child becomes an adult, and every child as an adult has an opportunity to create a new child. So let's just do that. Well, let's see. Let me reset it and create the abundance. Now every child becomes an adult, and each adult procreates. And we see here that this population is not decreasing. In fact, it's quite steady. It's not increasing, it's not decreasing. It's an exact steady state. Well, let's look and see what happens if we change the fertility rate. Fertility rate is the number of children per adult. More often, this number is described as the number of children per woman, but in this case, in this exercise, we'll say the fertility of one means that each person is replacing himself or herself. Let's just redo our little experiment a little bit. Let's just seed the population with 10 children. Some of them are dying, half of them are dying in this example. And again, we see after some period of time that the population disappears. Okay. Well, let's, as we did before, let's create some abundance. So I'm going to start it over. I'm going to create an abundance of child health care. And again, we see that the population is forming a steady state. It's not disappearing, it's not growing, it's not decreasing, it's keeping its number about the same. Well, what happens if we suddenly increase the fertility of the adults to 2 children per adult? Let's do that. I have a little slider over here to allow us to do that. There. Now every adult's creating 2 children. And whoa, population explosion. We get a population explosion. So what have we learned so far? Well, we learned that for a different, for a given child mortality rate, that there is a certain fertility rate, let's call it the replacement fertility rate, at which the population maintains a stable size. If the fertility is less than that rate, then the population fades away and disappears. And if the fertility is greater than that rate, then we have a population explosion. So we can express this in an influence map as I have drawn here. We start out on the left. Child health care improves. That leads to children living. that increases the population, which you see right here. Now we have a choice. If the fertility doesn't go down, if it stays the same or increases, then the population explodes. On the other hand, if the fertility somehow adjusts to the population or adjusts to the child health care, then we can lower the fertility. The fertility can lower itself to a stable replacement level, and the population can continue on. So that's where we are right now. The big mystery, or the big mystery here from our very, very simple model is, does fertility adjust to population size? And this is really quite clear. It's just come out of this very, very indeed simple model. So what are other consequences of our little model? Well, we're going to assume that fertility adjusts to the size of the population, or rather to how many children are being born, such that there is a replacement fertility rate that stabilizes the population. If we don't do that, then the population just disappears in a population explosion or in a drought, and that's it. The population is controlled by resources. Well, so let's talk about what happens if fertility can adjust itself. The next thing that happens is that there are women, plentiful women, to join society, to join what was formerly a male society. Women who are not having or not engaging in childbirth and child rearing now have the ability to enter the workforce, to enter other activities that were originally in the realm of men. And we can see this down here in this box we added. Reduction in fertility rate increases the number of women in the workforce and in society. The number of women who enter society increased because the fertility dropped. They spent less time in childbearing and in raising children. So then women can now have the opportunity to enter the labor force in greater numbers. In 1890, 20% of the labor force was women. Now, today, the majority of the labor force is women. As women entered the labor force, economic growth expanded. We've seen tremendous economic growth and productivity increase since World War II, and a large part of that is due to the influx of women into the labor market. As women entered society, the role of men in society diminished somewhat. The major occurrence was that men were no longer the sole breadwinners in the family. As the role of men in society diminished, there occurred a cognitive dissonance among men. Cognitive dissonance and cognitive resonance are opposites of each other. So this increased cognitive dissonance or reduction in cognitive resonance created many things in society, among them the nostalgia voter. The nostalgia voter, typically in the U.S., is a white male uh, voter who longs to return to simpler times in the past, and they're quite common now. Well, what have we learned? Our goal was to identify a potential abundance and discover the consequences of the abundance. And we were going to do this by using thought experiments. In the tutorial, we examined the implications of an abundance of infant and child health care. In the process, we created simple images and models in order to help with the creation of the thought experiments. And they are indeed very, very simple. Finally, we wrote down the consequences of the abundance in the form of an influence map. This map can be used to build more quantitative models of society and can be used by policymakers to guide decisions. In our exploration of child and infant health care, we discovered a possible causal link between infant mortality and male emotional discomfort. This was not obvious at the start of the game, not obvious to me, perhaps it was obvious to you. These are the aha moments that we are trying to uncover, that we're seeking in this exercise. Well, this is Roger Jones coming to you from steamy downtown Pensacola, Florida. If you want to meet up again in space-time, go down below or at the end of the video and subscribe. Thank you very much. Be safe. Bye-bye.